Question 3, the lengths of the bolts, and this time we don't know what distribution they have, but they do have a mean of 3.03 and they do have a standard deviation of 0.2 centimeters. And we're going to do a sample of 100 of them. And so now, using central limit theorem, this will mean that the mean of those 100 bolts would be normally distributed with a mean of 3.03 and a variance of the standard deviation squared divided by 100 because there's 100 of them. And what do we want? We want to find out the probability that this sample mean is less than 3. So we can just do that on the calculator. Let's put that up here. And we want less than, less than 3 with a standard deviation of the square root of 0.2 squared divided by 100. That's going to be tiny, isn't it? Oh, just 0.02. Okay. And the mean is 3.03. And so that probability is working out to be 0.0668. Going on to part B then, a second sample is taken. The probability that the sample of this is less than 3 needs to be less than 1%. Find the minimum sample size required. So this time we're going with an N. Okay, so the mean of N of them is normally distributed with a mean of 3.03 and a variance of 0.2 squared divided by N. The probability that the mean is now less than 3. Okay, so we have to do this old style. So normalizing, sort of standardizing that is, so 3 minus 3.03 divided by the square root of this, which is 0.2 over root n, and we need this to be less than 1%, less than 0.01. Now I'm sure we could have some fun doing an n solve with all of that, but let's just do it old style way. So what we would normally have to do here is we just change to a standard one of standard deviation of 0 and a mean of 1. Standard deviation of 1 and a mean of 0. And we want this probability to be 0.01. So we're going all the way down there. And so this tells us that this calculation here needs to equal minus 2.326. So now we've just got an equation to solve. So 3 take away 0.03, so that's minus 0.03 divided by 0.2 over root n. Let's put that equal to each other there so we can actually just work out what n is going to be. So we'll get rid of the negatives. We'll times that up. So I'm going to get 0.03 root n equals, and what have I got there? That times by 0.2 is 0.4652. So if I divide that by 0.03, that gives me 15.5, and then I square that. That gives me n is equal to 240.4, and we want it to be slightly bigger than that, so n equals 241 is the minimum sample required before the probability is less than 1%. If you're worried about me losing the inequality sign there, I just prefer to do it with an equals, but this is where we were with that. I then times both sides by minus 1, and so that reversed the inequality there, and that's why I've got a greater than there That's why I've got a greater than there, and that's why I went to 241, the next one up. I just, rather than worrying about the inequality, I was just going for what is the critical value and then nudging it which side I need.